The first question, Matilda, maybe goes on the life sciences in general in your research field, which is the human microbiome. And where do you see the development going, and what is the development which makes maybe your research at the moment only possible?
So my research field really is focuses on the human gut microbiome and how it influences our health and well-being every day and through our entire life. So over the last decades, really we learn so much about the potential impact of the microbiome. However, I think now that we know how to do it, we need to investigate the causal effects, right, between the microbiome and health. So we developed so many techniques. We have all those knowledge, but we need to move on and investigate the a causal relationship, let's say, between the microbiome and our health. I will say that we also mostly so far focus on the fecal microbiomes, which is, let's say, a good proxy for what happened in the gut. So I think moving on, it will also be very important to investigate the structure and the function of the microbiome along the gastrointestinal tract. We will investigate the causal relationship. So for that, we've been, so us, but also others worldwide, we've been building comprehensive biobanks of those microbes that compose the microbiome. So we do have these resources available to really investigate experimentally the relation between bugs themselves, to understand their ecology, their relationships.
Before we go on and maybe focus a bit on key life sciences, but what are still challenges? I mean, and not maybe also technological challenges in your field, which have to get solved to move on?
So I think one big challenge that we have right now is actually investigating those bacteria that are located in specific parts of the GI tracts. For example, the bacteria that are associated to the mucus layer, those we know they are extremely important for human health. We know they interact very intimately with the human cells. So being able to culture them, isolate them, investigate them will be very challenging. And so that's the kind of challenges that are very complicated to address. But at the same time, here at Kiel, we are very well positioned actually to address them.
We are very happy that you're here, and also that you immediately became member of the Key Life Sciences, and you are actually already doing initiatives in Key Life Sciences. What's so special for you to be member of KLS?
We have in Kiel Life Science awesome scientists from very complementary fields, I will say. So I think this is extremely valuable, and yeah, I think that's really the power of Kiel Life Science, the complementary between the members. So we obviously have the same ultimate goal. We have the same interest in evolution, for example. That's always a topic that we share across all the KLS members. A lot of us are working on microbiome related topics, but in different hosts. So yeah, I think we have very complementary interest and expertise.
Does KLS offer everything what you need for your research? Is there something where you think you could be supported a bit more?
I think the support really from KLS is very strong in terms of visibility, in terms of organizing events that put together the KLS members, so we can create collaboration and so on. So yeah, I think that the support from KLS is extremely strong and valuable. And on top of that, so we are currently working on uh, the implementation of a new center at Kiel Life Science, so that will be really focusing on the microbiomes. And this is something that is possible only thanks to the support of KLS.
Would you share with us some of your ideas and visions of your own research in the next few years?
So we now have a very comprehensive and large biobanks of bacteria. So continuous flow bioreactors that will allow us to ask a very specific question using this biobank of bacteria. So and recreate what we call synthetic bacterial communities. So controlled and built consortium of bacteria from the biobanks that we can then put in the bioreactor, continuous flow bioreactor. So that means that we can maintain stable communities of bacteria over time and can test really experimentally in the lab several conditions and test for their impact of on bacteria interaction. But also, I think it's very important to investigate the microbiomes from various hosts. So through life science, we have several hosts, but even just for humans, investigating different human population, different human of different lifestyles. So for that, with Mathieu Groussin, with also a professor part of Kiel Life Science. We've been building the Global Microbiome Conservancy Initiative, and through this initiative, we have a consortium of about 100 scientists collaborating with us worldwide, and we are working all together to put the different human population of different lifestyles on the map of microbiome science.
Where do you see the life sciences from your perspective in future in the next year? So, what is needed and where will it go in your opinion?
Yeah, we'll say that we need to go beyond bacteria. So most of the people that are working on microbiome science focuses on bacterial species. That makes sense because they are the most abundant. We know a lot. We know a lot about their implication on human health, for example. But there is a lot of other players, archaea, fungi, and maybe even more importantly, I think phages. And I think that should be something that we should focus on in the future. We know that they are very important, but we know very little about them. And there is no biobanks of such phages, for example.